Hi everyone. So as we know, this is the second part of meshing tools as we were discussing it before in the first part. So now we tried with the standard mesh, and if standard mesh doesn't work, we can always try curvature based mesh. We can right click on the mesh and create a mesh. So instead of using standard mesh, we can go with curvature based mesh. So let's click here. Curvature based mesh recognizes curvature on the surface and edges and increases the mesh locally in these regions. So this is a powerful tool, but the disadvantage is that it affects all the fillets and all the components on the surface. And when you try increasing the mesh density in the flat region, that can lead to a collapsed element. But it's worth to try. So let's go here, and with the curvature based mesh, here we have maximum element size, so let's leave as it is. And here we have minimum element size. Let's go to the most minimum as possible. Here we have minimum number of element in a circle that specify the number of elements in a circle. So we have a circle like here. The minimum number of element will be 8. We can increase this to maximum, so let's go to 36. As well, if you go to the advanced option, here we have Jacobian that we talked about before. This is numerical measurement of the accuracy, and the option sets the number of integration points to be used in checking the distortion level of the tetrahedral elements. So you can choose here for 1629, but let's go with 4. Let's leave as it is. And now if we go closer, we can see that everywhere we have curvature here inside our smaller elements. So this is much smaller than this one here. So everywhere like if we go here and down here, we have small elements here. We have small elements here as well. We have affiliate, and we have small elements here and here. Right click and details. We have 86,000 nodes, and this is pretty much big number, and our maximum aspect ratio is above 10. So the curvature based mesh didn't help us, and the time to complete the mesh was 7 seconds compared to the first one where we had only 3 seconds. So this is not really a good result. So let's exit and let's double click on the mesh quality aspect ratio. So let's find the maximum aspect ratio, and the maximum aspect ratio is here. As we see, this element is flattened here, so the curvature based mesh is worth trying, but increasing the mesh density in all regions, and this is really not what we want, but it was worth trying. Now as we saw, the curvature based mesh applied higher mesh density to all curvatures in our model. This is not what we wanted. So for example, we want to select on which surface edges we want to create denser elements, and usually those surfaces will be the biggest have the highest aspect ratio, and in the region where we expect the highest stresses, for that we can use mesh control. Apply mesh control to a local region allow us to create a fine mesh with high number of elements where we anticipate higher stresses. So where we have a smaller element size, the higher the accuracy of the calculation is. It's a basic principle. So it's always the balance one, that hand with the number of element and the other hand with the shape of the element. So now let's go to mesh. Let's right click and let's click here, apply mesh control like this. And first here we have to choose faces, edges, vertices where we want to apply mesh control, and says the higher stresses will be here. We anticipate that higher stresses will be here. Let's choose this edge like this. Now here we have to choose element size. Let's go with 1.4 like this, and let's click OK. Now let's go to our mesh. Now as we see, we have here a new folder, mesh control. If we open this, we have here control 1. Now let's go to our mesh. Let's click here, create mesh, and let's go with the standard default mesh, reset, and let's go to standard automatic transmission of the let's click OK. Now if we look at our mesh, we can see that around the edge we have smaller elements, and in the other region of this model the elements are the same size. So let's go to mesh, right click details, and we have total nodes 15,000, and this is pretty much good. But look at our maximum aspect ratio, which is 16.32, and that is not really a good aspect ratio, and the time is here 3 seconds. That's good. Let's see where we have the maximum aspect ratio. Let's double click and we get our mesh quality. So the maximum aspect ratio is on this edge here, and here we have a problem on this side and on this side as well. So maybe we should apply the mesh control on those two edges. So let's go to the control, right click and add a definition. So we have edge 1. Let's add this edge here, and let's add this edge here as well. Let's click OK. Now let's go to mesh, create a mesh. We have a standard value. OK. So we had the standard values and OK. And now you see we also have smaller elements on this edge and this edge. Now let's go to mesh details. So the number of total nodes is more than 18,000, but the maximum aspect ratio is 4.6, and this is really good, and the time is 3 seconds. So this is so far the best result that we got. So we got the maximum aspect ratio below 5, and we don't have so much total nodes. In the first case we had 13,000, now we have 18,000, but in some cases we had 80,000. So this is pretty good. So let's see where is the maximum aspect ratio. Let's double click here. So the maximum aspect ratio is still here, but this is 4.6, and this is pretty good. So this is acceptable for us, and we're going to accept this. And now we are pretty much sure that we are going to get pretty much good results of stress, displacement and strain. So remember, when you create a mesh, on the one hand you have number of elements. You don't want to have a lot of elements because that increases time and memory. But also where you have smaller elements, you may have a better accuracy ratio. Especially you want to have a smaller elements in area where you predicted high stresses, because you want to get a good result in those regions. So pay attention to the total nodes, maximum aspect ratio, and the area where you predicted the maximum stress and the time of the calculation. So this was all about the mesh topics that we were covering in these two parts. In the first part we covered about mesh and model simplification, standard mesh, and in this second part we covered about curvature based mesh and mesh control. I hope these both sessions would be helpful for you. So stay tuned for more videos. We will be uploading on this channel only. So subscribe to this channel. Thank you so much.
Do subscribe our channel and hit the bell icon.